The year is 2500 BC in ancient Egypt. This is the Khopesh. While it resembles a sickle, it is technically the evolutionary link between a battle axe and a sword. Its specific geometry is designed for control. The hooked spine allowed soldiers to snag an opponent's shield, pulling it down to expose the neck or head. Unlike a balanced sword, its mass is concentrated near the tip. This distribution generates high kinetic energy, delivering crushing blows capable of compromising the leather armor of the Bronze Age. It was a weapon of high status. Even Pharaoh Tutankhamun was entombed with two of these blades. However, as metallurgy advanced, the Khopesh faced a critical flaw. It was heavy and expensive to cast in bronze. By 1300 BC, with the rise of lighter, stronger iron weapons, the Khopesh was abandoned on the battlefield. The setting is the Iberian Peninsula, roughly 200 BC. This is the Falcata. Its geometry is a masterclass in weight distribution. Unlike a straight sword, the blade widens near the tip, shifting the center of mass forward. This engineering creates a specific kinetic advantage. It delivers the chopping momentum of an axe while retaining a sharp point for thrusting. The handle is equally deliberate. The hook-shaped grip almost encloses the hand, allowing the user to swing with maximum force without risking weapon slippage. Its structural integrity was so formidable that, during the Punic Wars, Roman legions were forced to reinforce the edges of their shields with iron strips to prevent the falcata from splitting them. However, the falcata was difficult and expensive to manufacture. As Roman standardization dominated the region, this complex design was replaced by the mass-producible gladius. By the end of the 1st century BC, it had largely vanished from military use. The timeline moves to the rise of the Roman Republic, roughly 200 BC. This is the gladius. Unlike the falcata, this weapon is not designed for individual flair, but for industrial-scale warfare. It features a short, straight blade with two parallel cutting edges and a rigid, tapered point. The mechanics are dictated by the formation. In a tight Roman shield wall, swinging a long sword or an axe is physically impossible due to lack of space. The gladius's short length allowed a legionary to stab through small gaps between shields without exposing his own body. Its structural rigidity meant that a thrust of just 5 centimeters was often fatal. It was the ultimate tool of standardization, manufactured by the millions to equip the legions that expanded the empire. However, as warfare evolved towards looser formations and cavalry dominance, reach became more critical than close-quarters maneuverability. By the 3rd century AD, the gladius was phased out in favor of the longer spatha. We enter the Viking Age around 800 AD. This is the Ulfberht. The engineering significance here lies not just in shape, but in metallurgy. While most European swords of this era were made of soft, low-carbon iron mixed with slag, the true Ulfberht was forged from crucible steel, likely imported from Central Asia. This high-carbon material provided a physical anomaly for its time. The blade was both incredibly hard and flexible. The wide central groove, or fuller, is not for decoration. It removes mass to shift the balance point back toward the hand. This physics adjustment allowed a warrior to recover the blade faster after a swing without compromising structural rigidity. It was arguably the first luxury brand in military history. The specific inscription, plus VLFBERH plus T, was so prestigious that lower quality forgeries with misspelled names flooded the market to deceive buyers. However, as trade routes to the east collapsed and European forging techniques evolved to produce domestic high-carbon steel, the specific Ulfberht pattern faded. By the 11th century, it had evolved into the standard knightly arming sword. We moved to the Ottoman Empire, peaking around the 15th century. This is the Kilij. It represents a significant evolution in curved blade geometry. The defining engineering feature is the yelman, a flared, double-edged section at the tip of the blade. Physically, this addition serves a dual purpose. It shifts the center of percussion forward, increasing the kinetic energy delivered at the point of impact. While the deep curvature facilitates a draw cut, slicing through targets by pulling the blade back, the weighted yeoman allows it to strike with the crushing momentum of an axe. This hybrid mechanic meant it could slice through light protection or smash through rigid helmets, making it the ideal weapon for heavy cavalry charges. Its design was so effective that it directly influenced the shape of European cavalry sabers for centuries. However, with the modernization of the Ottoman army and the dominance of firearms, traditional swordsmanship declined. By the late 19th century, the Kilij was replaced by standardized, European-style military sabers. The timeline advances to late medieval Europe around 1350 AD. This is the longsword. While often mistaken for a brute force tool, its design is based entirely on the physics of leverage. The extended grip allows for two hands, one near the crossguard, the other on the pommel. This creates a fulcrum effect. By pushing with the forward hand and pulling with the backhand, a swordsman can generate rapid tip velocity with minimal arm movement. Structurally, the blade is rigid and tapers to a fine point. This allows for half-swording, gripping the sharp blade with armored gloves to use the weapon like a short spear or a mace. This was a mechanical necessity to bypass the plate armor of the era, which could not be cut through. It was not just a weapon, but a science. Its techniques were documented in complex geometric manuals by masters like Hans Talhofer. However, as firearms rendered heavy plate armor obsolete, the need for such a large, armor-breaching sidearm diminished. By the early 17th century, the longsword had largely evolved into the lighter, civilian-focused rapier. We arrive in feudal Japan around 1400 AD. This is the katana. Its defining engineering achievement is not just the shape, but the differential heat treatment. By coating the spine in layers of wet clay before quenching, smiths created a composite structure within a single piece of steel. The edge cools rapidly, becoming extremely hard to retain a razor-sharp edge. The spine cools slowly, remaining soft and flexible. Physically, this duality is critical. The soft spine absorbs the high-frequency shock waves generated upon impact, preventing the brittle edge from shattering. The curvature itself is largely a byproduct of this cooling process, which naturally bends the steel. This curve facilitates the draw cut, allowing the blade to slide across a target, maximizing the slicing mechanic rather than acting as a wedge. However, the modernization of Japan brought a swift end to this era. With the Haitorai Edict of 1876, the public carrying of swords was banned. The samurai class was abolished, and the katana transitioned from a weapon of war to a ceremonial relic. We conclude in the Holy Roman Empire, early 16th century. This is the Zweihänder. Its engineering is defined by scale and leverage. Reaching up to 2 meters in length, it functions less like a sword and more like a steel pole arm. A key mechanical feature is the parrierhaken, the parrying hooks found above the guard. Physically, these lugs act as a secondary crossguard. They allowed the wielder to grip the leather-wrapped, unsharpened section of the blade safely. This shortened the effective lever arm, instantly transforming the massive weapon into a short spear for close-quarters grappling. Its primary mechanic, however, was rotational inertia. By swinging it in wide arcs, soldiers could generate enough momentum to smash aside or shatter the wooden shafts of enemy pike formations. This high-risk role was reserved for the Doppelsoldner. Mercenaries paid double wages for facing such danger. However, as gunpowder units were integrated into pike squares, large, unshielded shock troops became easy prey for arquebuses. By the late 16th century, the Zweihänder was retired from combat, surviving only as a ceremonial bearing sword.